Oh no.
Okay. All right. So 7-2 is going to be differentiating and undoing the differentiating, which is integrating, of exponential functions. So they start by giving us a graph, and on the notes that you watched, you learned how to graph e to the x, right? Yeah. So it has a y-intercept of 1, right? So it goes through at 0, 1, and then the other point was 1, e. And you guys remember that e was like the value of
7.
Yeah, so there's my perfect drawing. Okay, which is relevant for what we're doing today, but there you go. Okay, so they give us 4 differentiating rules. Okay, so take a look at these. I know that when you're just looking at them, they're not going to absorb into your brain. So I don't know if you need to like rewrite them down or like say them out loud or maybe just practice them. I'm going to say that this is rule 1. Okay, so the derivative of e to the x is really hard. It's e to the x. Just kidding, that was easy. Okay, number 2. The derivative of e to anything other than x is e to the anything other than x times the derivative of that exponent. Okay, so the idea of number 2 is remember that you have the hook-on factor. Okay, so if I multiply by a hook-on factor when I am deriving, you have to remember that that is on the outside. Okay, from the chain rule, that's where it comes from. Okay, now 2, this one is going to be, nope, I lied. This is going to be called number 3. Number 3. And this one's number 4. Okay, what do you notice about 1 and 2 versus 3 and 4? Basically the same. But they add in a natural log, and what do you notice about the base number? A. Okay, A is representing some constant. Okay, so if the base is not an e, you have to also multiply by the natural log of the base. Okay, which technically the number 1 does, because if you multiply by a natural log of e, what's a natural log of e? It's 1, yeah. Okay, so that's why they don't write it. It's because it's 1. So since math is the let's do everything really quickly idea, we just don't write it. Okay, let's do this. Okay, so number 1, which rule am I going to use? 1, 2, 3, or 4?
1 or 2.
Number 2, okay, because you got a base of e, so we know it's 1 or 2, and the exponent is not x. So we're using number 2. So all you do is you just write what's given to you. So our derivative is what's given, and then just times the derivative of the exponent. So what is the derivative of the exponent? 2x minus 3. Done. No, you leave it like that. Right. Okay, what about number 2? Which rule am I using for number 2? 1, 2, 3, or 4? It's a base of e, and it doesn't have an x, so that's a number 2. Okay, so number 2 says, I just write what's given, and then I have to multiply by the derivative of the exponent. So remember the exponent, 3 over t is the same as negative 3 times t to the negative 1. Right? So what's the derivative of negative 3 times t to the negative 1?
3 over t squared. I'm thinking it's 3 over t squared.
Yeah, 3 over t squared.
Oh, 6.
I don't know where you added us 2 from.
Over t squared.
Over.
So technically, you can just make that 2 negative.
You know,
Yeah,
I feel that
right.
spreading.
So, yeah, your call on if you want to simplify. All right, what about number 3? Which rule is number 3? 1, 2, 3, or 4? Base is 3, not an e.
I'm reading this number one.
It's number 4.
Oh.
See how the base is 3, it's not e? Okay, so remember this is the same as 3 to the v to the 1/2. So we're going to have 3. Okay, and then we have to multiply by the derivative of the exponent. So the exponent is v to the 1/2, so what's the derivative of v to the 1/2? 1/2 v to the negative 1/2. And then I also have to multiply by the natural log of my base number. Okay.
So can it like drop it down to make the v to the 1/2 positive be 1/2?
Absolutely. Yep. And if you wanted to write it as a single fraction, like if you would probably like you wouldn't want to have like a million different fractions. This is probably the most simple. But yeah. Or whatever. So obviously multiple choice they might simplify it, so you just have to recognize what's equivalent to that. Right. If it's a free response, well, you don't want to simplify a natural log of 3 because the natural log of 3 is exactly the natural log of 3. If you type it in the calculator, you'll have to round it and get an approximate answer. Okay, so here is number 4. So this is the whole idea of now we have the ability to find the tangent line at any equation. Okay, well, not any. We still have to do trig functions, but that'll be next chapter. Okay, so they ask us to find the relative extrema. Okay, so that's fancy. What does that mean? The mins and maxes, right? So how do I find mins and maxes? Exactly. Take the first derivative and set it equal to 0. So how am I going to drive this function? Which rule am I going to have to use?
The first.
Okay, we're going to use the or the second rule because it's a base of e. But we also have an x being multiplied. So which?
First, second times.
Yeah, exactly. We have to do a product rule here. We have two things that are being multiplied. There's a negative x being multiplied by an e to the negative 2x squared. So it's a product. Okay. What's that? E to the negative 2x.
So it's just use the first one.
The first, yeah. Mm-hmm.
But since it's e to the negative 2x.
Yeah, it's not an x, right? It's more complicated. Okay, so first is negative x, d second. So I have to derive the e to the negative 2x squared. So to derive that, I'm using my second rule. So it's going to be e to the negative 2x squared times the derivative of the exponent, which is negative 4x, plus the second e to the negative 2x squared times the derivative of the first. What's the derivative of negative x? Negative 1. Okay, so we said we have to derive it and set it equal to 0. So I'm going to set it equal to 0, and I'm going to simplify in this step. I see negative x times negative 4x. That makes 4x squared times e to the negative 2x squared minus e to the negative 2x squared.
You didn't put that x in. Yeah, you have to distribute the negative x to the e too.
Well, it's just three things that are being multiplied. Because it's times the negative 4, not minus. So it's like, I think you're thinking that's a minus instead of a
Like
multiply. Yeah, exactly. Commutative property.
They're still being multiplied eventually.
Exactly. It's like 2 times 3 times 4 is the same as 3 times 4 times 1, or whatever I said. I didn't say that right. But you can change the order. So I just grouped the x and the negative 4x together. It's not distributive property, because it's times negative 4x. Okay, what do I do now? How will I solve this one? Well, let's try not using a calculator. How about pull out a greatest common factor? Yeah, you can take that e out. So we have e to the negative 2x squared out of both terms. So the first term I'll still have a 4x squared minus 1. Good. And then since that's set equal to 0, I can set each piece equal to 0. Okay, how do I solve e to the negative 2x squared? Oh, nice. You have the right idea. So negative, or the natural log of 0 is equal to the exponent. Remember that? So here's maybe a side note if you can't remember, if you don't remember. Remember if you have b to the x is equal to y, the equivalent logarithmic form would be the log of base b of y is equal to x. So those two things are equivalent. Remember that? That was a while ago. Okay, so what's the natural log of 0? So here's another way to think of this. If I didn't convert it to natural log form and I kept it in exponential form, what exponent would make e turn into 0? It can't be 0. You're exactly right. It cannot be 0. There's no way for me to have an exponent of e and make it become 0. E times itself will never become 0. Okay, so this is going to give us a no solution. Not possible.
Like those.
Yeah. So over here on this side, we can get a solution from this one if we add 1 and divide by 4. And then, yeah, square root. So plus or minus 1/2. Everybody good on that equation? Okay, so then I have to do my number line. And my positive and negativeness. Okay, so let's plug in -1. Okay, so when I plug this in, I have to go back to the first equation right here. So if I plug in -1, if I have e to the -2 to the -1 squared, so that's just e to the -2. Remember, a negative exponent just creates a fraction. It's the same as 1 over e squared. Is that positive or negative? That's positive. So this piece would be positive. If I plug -1 into this piece, I would get 4 minus 1, which is positive. So I have a positive times a positive. So this interval will be positive. Okay, if I plug in, let's use 0 for this one. So this becomes 0. So what's e to the 0? 1. And then times -1. So what is that one? Negative. And then if I plug back in positive 1 will be the exact same as plugging in -1 because everything was squared, right? So I'll get a positive out on that scenario. Okay, so we got an up, down, up. So where is my max? -1/2, yeah. So the max is at -1/2, and what did they ask us to find again? Points. Oh, yuck. Okay, so points. Yeah, so I have to plug this in. I'm going to make this super simple and leave it like, I'm just going to plug it in. So if I have, yeah, plug it into the x, so I have -1/2, so it'll be 1/2. Yes. Yep, go back to the original. And then if I plug in 1/2 into the exponent, that's 1/4 times -2, so -1/2. E to the -1/2. I'm going to leave it like that. Let's not get too carried away. And then the minimum, yep, into the original. So minimum x value is a +1/2. If we plug +1/2, we'll get -1/2 e to the negative 1/2 again. We'll just leave it like that. Okay, so remember that anytime you're deriving, you're still finding the slope of the tangent line or the instantaneous rate of change. Right? It allows us now to use exponential pieces. All right, so let's undo that. Let's integrate. Okay, so rule 1 correlates with this rule 1. That's the undone version. This one would be 2, this one is 3, and this one is 4. So remember, on rule 2, we had to multiply by the hook-on factor. So when we integrate, what do we have to do? Not in the exponent. You just put a plus c at the end. But how do you undo the hook-on factor? If it was originally multiplied, when we undo it, what do we have to do? Divide. We have to divide by it. Okay, so maybe give yourself a hint right here that you have to divide by the hook-on. And remember, the hook-on is the derivative of the exponent. So maybe write divide by the derivative of the exponent, whatever you remember. Okay, so question number, not question. Rule number 4 is the same thing because it has that hook-on factor again. You have to remember to divide by that. Okay.
Is it pointing? Where is it pointing?
Where am I pointing?
Where is your arrow pointing?
Just to the whole rule, just generally. In the, like, after the E. So like you might write, this piece right here might become e to the u divided by du. Because you have to derive it plus c. If that helps to remember. Or let's just practice it and we'll just see what happens. Okay, so number 5. It gets out at 36. So we got like 10 minutes. We're good. Okay, so number 5, which rule am I using? I have a base of 4. I'm ignoring that x that's on the outside. Focused. Kaik, focused. Thank you, Kaik. You forgot somebody. No, but next time. Okay, so we're looking at rule number 4. Right, number 4. Okay, so I'm gonna just write what is given. I'm gonna put the x in the front because I don't know why, it just feels better up there. Okay, then I have to divide by the derivative of the exponent. What's the derivative of the exponent? 2x. Okay, and then did you guys notice on this one they give us a bounded region? Okay, so do I need a plus c at the end? No. Yeah, you do big minus little on this. Okay, so now if I integrated this correctly, the x's on the outside should cancel, which they do. And, oh, you guys, what did I forget?
Plus c.
Oh, we're doing number 4. What did I forget in the bottom? Number 4. I did the derivative of the inside. I forgot natural log. Natural log of 4. Okay, so when the base is not e, you have to always do the natural log of the natural log because the base is 4. I don't know. I just felt like it looked better over in the front.
Is the x just part of the original function?
Yes.
Okay.
Mm-hmm. It was given.
Alright.
Alright, so I'm going to do big minus little right now. And since we have a 2 natural log of 4 on the bottom, I'm just going to pull it off in front so I don't have to deal with it when I do big minus little. So now I'm going to plug in the big. So I have 1/2 squared minus 1. Yeah, I'm just plugging it in. Big minus little. It says find.
It's still
So what's 1/2 squared? 1/4 minus 1. Negative 3/4. And then on the other exponent, I have 0 minus 1, which is negative 1. And I'm going to leave that like that. You got to do a little bit. You still got to plug in. Okay, number 6. So which rule am I looking at for this one? We have a base of e, and we have an exponent of 2 over x. I'm going to ignore the stuff that's on the bottom for a second. That's going to be my outside. Okay, so we're looking at rule 2. Okay, so I'm going to have e to the 2 over x. Remember that 2 over x is the same as 2x to the negative 1. I have a big bottom, so I'm going to have 3x squared, which was there. I have to multiply by the derivative of the exponent. What's the derivative of 2x to the negative 1? Negative 2x to the negative 2. And then what do I also have to include? Oh, no, I don't. The natural log of e is already 1, right? That's just the derivative of the exponent.
Yeah. So does that mean it bumps the negative 2 up and the x squared will cancel out?
It does.
Dang.
So can we do that mentally? Do you guys see how the x squareds end up canceling? Because if you have a negative in the bottom, it moves it to the top. So then you have an x squared over x squared. These cancel. So what's left in the bottom?
3.
What?
3.
Negative 6. Don't forget your 2. Negative 6.
You can't just bring negative 2 up to.
No, it does not have a negative exponent. Only the x does.
I thought it was attached to the negative 6.
Okay, last one. Okay, this one, you can't high this because it's an integral.
That's what I tried to explain to Matt.
You can't integrate. High is only deriving. Okay, I'm going to rewrite this one. So I have e to the x minus e to the negative x. And all I'm doing is I'm pulling that denominator upstairs to the negative 4th. Okay, if I have a quantity that has an exponent, which integral rule do I have to use?
Power.
The power rule. Very good. Okay, so I am going to do a power rule. I'm going to ignore the first quantity and hope and cross my fingers that it cancels. Otherwise, I would have to do a u substitution. Okay, so I'm going to do. We're going to ignore it, and then we're going to add 1 to the exponent. So what's my new exponent going to be? Negative 3. I have to divide by that exponent by the chain rule. And now I have to derive by the derivative of the inside. So what's the derivative of e to the x? E to the x. What is the derivative of e to the negative x? Close. Remember, that's a rule 2, so I have to multiply by the derivative of the exponent.
Can you explain how it's
Yeah.
plus?
How is the derivative of e to the x? E to the x? Rule 1. First rule. E to the x, derivative is e to the x. Integral of e to the x is e to the x. So you're going to have, so e to the negative x is e to the negative x. What's the derivative of negative x? Negative 1. So see what happens here? On the bottom, I have plus, whoops, I didn't draw the negative. It turns into a minus. So see now how the quantities can cancel? Because of the minus?
Oh, maybe that was practice.
Yeah. So I'm going to go ahead and take that quantity that has the negative 3, put it downstairs, so I have only 1 left on top. So I have e to the x plus e to the negative x cubed plus C.
Remember how you said like we started doing it with
It will. It will. It will click. It will. Okay, so here's your plan, you guys, or my plan, our collective plan.
the plan that we have.
The plan. So tomorrow I will see you first thing in the morning, right? Your assignment is to do problems 1 through 23. Okay, now listen, hold on, chill out.
I can't chill out.
Okay? Tomorrow we have our 90-minute class, right?
Yeah.
Okay, so I'm going to give you like a half an hour to work on this assignment, and then we will start 7-3. Okay, so I'll give you some time in class.
Easier than